Hi. So I'm going to speak about VBA today. Let's get one thing first out before we start. VBA means Visual Basic for Applications, and I'm actually talking about Office macros. So why Office macros in 2019? First, I will present, I will do some shameless self-presentation. Then we're going to have an introduction into why Office macros are still a subject now. We're going to look at Emotet, a malware that is using macros, and obfuscation techniques that are used in macros to hide what they're doing. And we're going to look at an implementation of a security framework that we developed to run macros and see what they're doing. And finally, I'm going to have some references for you, and I'm going to accept your questions. Okay, so first of all, who am I? I have done my PhD degree in the south of France in Eurocom, and I've worked on embedded systems, backdooring a hard drive, and testing firmware. Now I'm in Talos inside Cisco, and I'm much more on the malware side on PC, and we're doing detection, analysis, and defense. Okay, so why analyze VBA macros? They should have been dead long ago, probably. Well, there are a couple of things why they're not dead. So first of all, to clarify what we're speaking about here, we're speaking about Visual Basic for Applications. There's also another type of macros, which are Excel 4.0 macros from 1992. Those ones are also used in malware, and they're pretty interesting, but they're out of scope for this work. And the problem, or why we still have macros around, is because there are many legitimate uses for it. In a company, people want to express custom formula, or they want to connect to a database, fetch data into the Excel sheet, and then manipulate it there. And this is actually wanted, and I think this ambiguity between not having macros because they can contain malicious code and the legitimate use is carried in this small yellow bar that Microsoft is showing when you open a document with macros that tells you, do you really want to run them? Because normally you don't want to run macros that come from the internet, but if you click yes, then you still have the ability to run macros. And malicious code might use hooks to automatically execute itself just when you open a document, when you click a cell, and so on. And yeah, so now I've answered why macros are still around, but why are they used by malware? Why are they a threat? So Emotet is a Scourge that is has been around since 2014, I think. Initially, it was a banking Trojan, and then it evolved to a malware delivery platform. And one way Emotet is infecting machines is via Office macros. So we could go and we could just dump the code that is behind the document to extract the macros and see what they're doing. There are tools for that. There is Philippe Lagadec's OLE-VBA and ViperMonkey. OLE-VBA is a tool to just statically look at the code and try to extract things that are suspicious. ViperMonkey goes a step further and parses code snippets and then translates them into Python and executes them in Python to see if they have malicious behavior. The problem is that ViperMonkey is an approximate tool and thus fails if the code is heavily obfuscated. And OLE-VBA, as it is a static tool, if the code is obfuscated, cannot do anything. The problem is that we could also do dynamic analysis. Dynamic analysis currently means that we load the document into a virtual machine, start Office on this virtual machine, run the document in Office, and then collect all the observables inside this virtual machine that happened during the execution. There are several disadvantages. First of all, we need to spin up an instance of VMware or whatever and run a virtual machine, which is expensive. We don't really know when the execution is terminated because we don't know when the macro code has finished executing because we don't have visibility into Office. And then we get tons of observables that are pretty noisy. We have the operating system artifacts, we have the artifacts from Office, and we have somewhere inside the artifacts from running our code. But then you need to extract them. So the idea we had was to interpret the macro code ourselves. Oops. Okay, but before we go into interpreting the macro, let's look at how a typical emotet infection looks like to get a feeling of what we are faced with. So typically, everything will start with an email like the one you see here. The emotet is pretty good in social engineering in that when it infects a machine, it extracts 88 days of emails, and it will contact the persons that the emails were written to and just reply to the existing email thread. So you get an email from a person that you know. You get an email thread where you have sent messages yourself in that you recognize. And this makes that the email thread is quite believable and that you will probably open the document that is now being attached by emotet. Okay, so the next step is you clicked on the attachment, Word is opening, and you have this yellow bar here where it says enable content. And of course there is a nice message in the document saying, yeah, this document cannot open, you need to click this bar, otherwise you will not see what is to be seen. So you will click the bar, and then the VBA code starts executing. The easiest way or the way emotet uses is it just uses an auto-open function, which is executed when the document opens. And then, this is a bit tricky with the micro. So then what the code will do is it will get an instance of a Win32 process Windows management interface class. And with this instance, it can open a process. And as an additional goodie, it hides the window of this process so that you don't see that the process is started in the background. Okay, then we create a process that is PowerShell with something encoded and a base64 blob, and that's it. So the PowerShell code is actually being executed. You can see here. You have a couple. You have a couple of URLs here, and the code is just cycling through the URLs, trying to download an executable from the URL. If the executable is downloaded successfully, it's invoked, and we're done. And then you install the actual executable, which will then go on and download later stages. It will steal your credentials. It will exfiltrate the 180 days of mails to attack your contacts. It will spread laterally in the network, for example, via Eternal Blue or some other vulnerabilities. And since 2015, I think emotet is also delivering other payloads. So it's not the most malicious payload itself anymore, but it will, for example, deliver TrickBot or ransomware, all this stuff. And at this point, we're pwned. So, of course, the code that I showed you there was very legible. The code that we get delivered in the document is not the same. So let's look at the obfuscation techniques that emotet uses to hide its code. First one is that code. So typically there is a huge amount of code, but only very few lines will do what Emotet wants to do. And one trick it uses is that variables in VBA are by default fails. So if you reference any variable that hasn't been initialized, it will evaluate it to fails, which is handy here in this while condition, where just some two variables that haven't been initialized are used, and the whole expression evaluates to fails, the code block is not executed, and this just confuses tools that are not able to understand this logic. So yeah, that code is not doing anything. Plus, there are line break. There's the line continuation character. This is used excessively. This is also just to confuse tools, because you need to interpret this whole thing as it was on one line. It's like the / character in C. Okay. Another technique is constant operations. For example, we can take a string and we can make it two strings that are being concatenated. Or we can use dummy content that we insert inside the string, and then we just use the replace function to remove the dummy content from the string. Or we can use a lot of useless typecasting, like you see here with the cvar, that actually doesn't change anything and will confuse tools. Another technique that I have seen in newer documents from the Emotet infections that started in September is this one here. Visual Basic is pretty special in the way it can do error handling. When you have a function or a procedure, you can say at the beginning on error resume next, or on error resume and the label, and it will go to the error handler you specified. So if you say on error resume next, it means if a statement fails, then just execute the next statement that follows the current one. You can imagine this a bit like having a try-catch around every instruction. And if you have a statement like here, and you cast something to an int that is clearly not an int, it would result in an error, and the instruction will be skipped. So just like it wasn't there. And this is also confusing analysis tools. Okay, another thing that is pretty annoying is the way Emotet stores its actual content, the PowerShell part that is then being executed. So you have the main Office macro code that is stored inside an OLE object inside the document. If the document is Office 97 to 2003 document, then it itself is an OLE document, and all the VBA projects and so on will be stored inside that. If it is a later generation, then the document is a zip file, and inside the zip file is an OLE document that contains the VBA project. Okay, and inside this same OLE file, we also have a couple of serialized form elements. Those can be used to create forms like you can put text boxes, command buttons, and so on. And there is a specification from Microsoft that is open on how to parse these content. And if we access the additional streams inside the OLE file where this content is stored, we can parse the form elements, and Emotet stores parts of its contents in the, for example, in the caption of a command button or in the text attribute of a text box. I haven't seen any tools that decode these streams. And in the one we implemented, we're decoding this, but we're just looking for the part that contains the Emotet strings. And there is also some obfuscation of the PowerShell code. First of all, PowerShell uses backticks instead of / characters to signify escape characters. So if you have a \n, this is a new line, but just inside a string. if the backtick n is outside of a string, then it is regarded as a line continuation character, just like the underscore I showed you before, or like the backslash in C. And if the backtick is not at the end of a line, it is just ignored. So the code here, actually, you can just remove the backticks and you have the valid code. Then a second obfuscation technique is, well, it's not really an obfuscation technique, it's just format confusion. When you pass a base64 blob to PowerShell, it will automatically figure out the encoding. So if you pass something that is UTF-16 encoded, like here, then it will automatically understand that it is UTF-16 and will correctly decode it. And that's a bit annoying because we need to do the same thing if we get the content. And finally, the same as in VBA, you have constant operations and case insensitivity, so that this expression here, which is one string, gets split into an array of several strings, and you need to handle this correctly. Okay, so those were the problems that we have. Now, let's find a solution. Yeah, so my first thought was, let's do it simple. We're just going to instrument VBVM DLL, which is the DLL that contains the Visual Basic virtual machine. And I found this function. It looks like this function is just taking an opcode and doing everything. So I decided, okay, we're not going to use VBVM and DLL. Also, the problem is that the integration between Visual Basic and Office is quite tight. So my initial thought was that maybe I can just take the DLL, I invoke one function in the DLL, I get my code executed, and I do this in a small sandboxed environment so that I can see what's happening. But since the integration with Office is very tight, it's not easy to just call a function in this DLL. So different approach. So this is where we went ahead and said, okay, let's try to interpret the code ourselves. And we looked for existing interpreters that are around there for Visual Basic for applications. And there is actually one in LibreOffice, which is called Star Basic. It is quite old. The parser is handwritten. It works, but it is the Star Basic is very tightly knit into LibreOffice. So whenever you try to access something, when you try to tear out the Star Basic code from LibreOffice, you will have a lot of dependencies that you need to resolve. And assuming, so I managed in the end to make the code run standalone, but then you still have a lot of UNO objects, which is the LibreOffice version of OLE objects that are not present because they were originally in LibreOffice and I didn't take them over because they have too many dependencies. So in the end, I gave up on trying to make this code work with a Python wrapper and looked for something else. Okay, so the second attempt. After a while, I found a repository in GitHub from a guy named Inshwa. I don't know anything more about him. I just mailed him to tell him that I want to use the code. And he told me, it's fine, but be very careful with the code. It was never meant to be used. So why this code? What's the advantage of this code over the other one? First of all, it uses Antler, which is a parser generator, and I don't trust myself to write a parser correctly. So I would rather have a parser generator that does that for me. And fortunately, the grammar that was inside this project comes from Zaddach, which is a plugin for analyzing VBA in a graphical interface. And also the specification is open, and Microsoft itself has provided an Antler grammar for alongside the specification. So that's pretty cool. The project is written in Java. Again, I don't trust myself to handle handle memory objects correctly and to handle to always check the sizes. So I prefer Java over C simply for this. And the project has a pretty cool interface to invoke Java methods from VBA. But the problem with this code was that the guy tried to make everything compile. So VBA is pretty dynamic in its nature, a bit like Python. So you can you can evaluate code at runtime, and you have a lot of objects that don't have a type that are known at compile time. And for these objects, it is hard to try to compile it statically. So I had to amend the project in this respect. So this yielded our implementation, where we start with a document with macros. We have a parser that is generated by our parser generator from an ANTler grammar. We get an abstract syntax tree that is actually never exposed explicitly, but is directly compiled to opcodes. Then we have an opcode representation of the program. This is pretty similar to what LibreOffice is doing. We're running this on our interpreter, and finally we get a couple of observables in a report. So, yeah, our implementation is a hybrid between LibreOffice and this VBA interpreter project. The parser is a lot slower than the LibreOffice parser because nothing beats a handwritten parser. But hopefully it is also a bit more adherent to the specification and more secure. Yeah, and the opcode representation, as I said, is inspired by LibreOffice. And the advantage of this implementation is that since everything is resolved at runtime, it is pretty easy to handle dynamic types, and it is also pretty easy to handle objects where you don't know what Emotet expects them to be. So if you want, you can do something like slightly like a slide fuzzer, where you give Emotet an object that is not initialized, and when it invokes a method on this object, then you generate a warning in the log from that. Our interpreter is a stack-based interpreter. The instructions are expressed as opcodes, values are stored on a stack, and a nested structure of dictionaries are our context, our scopes where our variables are stored. There are lots of intricacies that need to be handled. I showed before the on-error resume next instruction. So we need to handle this correctly in the interpreter, and we need to make sure that if an instruction is aborted during execution, that we clear up all the artifacts that were generated during the execution. And function return values are a bit tricky in VBA. So the way VBA denotes a return value from a function is that you just assign something to the function name itself. So it's like there is a secret variable that is initialized in the beginning to empty, and then you assign to itself, and then when you return, VBA will read this secret variable and return this value. Unfortunately, if you implement it exactly this way and you have a variable for that, it means that this variable will then shadow the function name itself. So when you try to recursively call the function after you have set a return value, then my implementation will find the return value instead of the function name. So this requires also some special handling. And the argument notation in Visual Basic is positively annoying. If you have something that is just a name, it means it can either be a variable or it can be a procedure that is invoked without arguments. So whenever you have a variable, you need to invoke the variable just to get its value, because it could also be a procedure that you actually need to invoke and execute code. So yeah, a couple of things that are annoying. Okay, let's look at how the implementation works. If you're already familiar with Java, how the Java virtual machine works, then this is nothing new for you, I think. we just start with a very simple program. We want to execute A equals A plus B. And we first push a string A on the stack. Then we have the find instruction that fetches us the variable named A from our dictionary of variables. We do the same for variable B, that we push the string on the stack. We find the value of B in our dictionary, retrieve the value. And then we have an add instruction that just pops the two top values of our stack, executes the addition, and puts the return value back. And finally, the write instruction, then we push again A for the variable we want to write to. And finally, the write instruction takes the two top values and writes the value to A. So that's pretty simple. What we get out in the end is a report like that. So what we have done is we have instrumented all the functions that are doing something that is malicious. We have the process window hide instrumented. We have the process start event instrumented. And of course, we don't execute them in the system. So this is an advantage of our sandbox compared to if you execute the VBA in a VM inside Office, that there you actually need to give the document access to the internet if you want to see what it does, or you need to emulate the network traffic. Here we can just extract the events like that. And then we can go ahead and decode the PowerShell blob with simple heuristics and be done with it. So how does this fare compared to our previous solution of spinning up VMs? Well, I'm pretty satisfied. Just this prototype that I currently have takes 1.2 seconds for a document. The whole, just from the execution from the command line, startup till finish. And memory usage is around 300 megabytes. And, VMs are also easy to parallelize, but here you just spin up several processes on the same machine. They don't influence each other, and you can have a couple of hundred processes on the same machine if your memory does allow you that. So the performance for just a prototype is pretty okay. Of course, that's not everything. There are some shortcomings. So one thing I didn't mention in the beginning is that Office documents carry several versions of macro code inside. There is the source code that is textual, but there is also a semi-compiled version that is called P code. And sometimes there is binary code. About this part, I'm not 100% sure when it carries binary code or not. If we have some time, I will go deeper into the P code, but for the moment, let's skip that. The code is currently in a very hacky state. I plan to clean it up and to have it in better shape, but that takes some work. And lots of stuff is not implemented. So currently, I only looked at the runtime functions I need. It is pretty easy to add new runtime functions. A lot of them are currently just commented, but this is work that needs to be done. And yeah, there is still some small things like correct handling of recursive functions. The project future is that I hope that we can put this as an internal service at first, where we will allow people who are doing investigations to submit documents. And also, I would like to hook our sample stream. We have, inside Cisco, we have a mail gateway, and we get documents from the mail gateway. So we have a couple of thousand documents per day for Emotet alone that arrive. And I would like to plug those documents inside the emulator and get the results from it, so that we can directly take then the URLs extracted from these documents and get the binaries, mark them as emotet, and carry the good detection that we have through the system. And currently the interpreter is optimized for emotet. I would like to also see that it handles RIDEX and other macro malware well. I've provided you with a couple of references. There are articles about emotet. There is the original repository that I used, the LibreOffice repository. P-code dump is a utility that is very cool to dump the P-code representation inside the document. ViperMonkey and all e-tools are the tools from Philippe Lagadec. And not now, but on Monday you should be able to download the code of this project here. I will also provide the slides, so as soon as the slides are online you should have the URL. Okay, let's go and have a look at the tool running. So first of all, I want to show you the output of all e-tools and ViperMonkey so that you have an idea of what these tools currently do. Oops. Voila. Okay, so this is the source code as it's extracted from all e-tools. You have something that you see that is missing here is the class module, which is not correctly, well, it doesn't have any code attached. It only has variable assignments attached, but these variable assignments are not exposed by all e-tools. You have the code that is being extracted. And in the very end, you have a list of observables that all e-tools extract from the document. A lot of them are very useful, like this here says it has an auto-open function, and it recognizes a couple of suspicious functions. But the problem is that now the emotet authors know that people are analyzing with these tools, and they also embed a lot of fails observables. So you have a ton of IP addresses here that I tried to figure out just with the whois if they target specific people with that, but it doesn't look like that. Okay, then. Hey. Then we have ViperMonkey. So ViperMonkey is just looking for certain expressions, parsing those expressions, and executing those expressions. It also works fairly well, but you will see that it will also exhibit some false positives. And in addition, it is not super fast. It's Python, and already the parser generator in Python is pretty slow. So you see it also found the auto-open. It found a couple of interesting functions like the caption and the Win32 process, but it doesn't show you the command line that is being executed. Okay, so let's get to our tool. So this is a representation of the source code that is being dumped by our tool. What was missing before is the project description. And this section here, which is the class module, which contains all the objects that are serialized. And finally, you also have, in the end, you have the serialized object contents. So this is where the actual emotet PowerShell code is that is then being used. And oops. This is what the tool execution looks like. So you see it's quite fast. It dumps you the whole blob of code here. And now you can go on and analyze what is inside. You can get the URLs and you can handle what's going on. So this brings me to the end. And the end are your questions.
Thank you so much. We have time for questions. So if you have any question, yes.
Thank you for your talk. You said that your tool was quite specific for Emotet. In what way, and what will you need to add to be able to analyze other tools, other malware?
So why it's quite specific to Emotet is because I used Emotet documents to go along in the development and to see what's needed. What is mainly needed for other documents is library functions. And so library functions plus looking at the library functions, what you should not do on your system. So for example, if it writes code to a file, you need to neuter this and you need to just write it in a temporary path where you can analyze it. Then, of course, at some point, the malware authors will come and they will write a file just to test if they're in the emulated environment. But this is something that I will see then. Also, if this appears very soon in Emotet, I know that they're following this presentation, which is interesting.
Other comment, question? Yes.
Still about the topic of the response of malware authors, how hard would it be for them knowing that such tools are being used to hide interesting behaviors?
This is the same question as for any sandbox. It boils down to a cat and mouse game. So at some point they will implement defenses against the sandbox, and then we will implement defenses against their defenses. So first of all, it depends on if they see us as a valid threat, and once they do, then we play with them.
Other question, comments? We still have time, yes? More? Same one?
In the case where you might want to adapt your tools for other malware, how would you ensure that a custom-made interpreter will implement the exact same behavior as the original VBA implementation, including all the corner cases, even the undocumented ones?
So the easy way how, at the moment this is still at the development stage, but my next step will be that I hook up the interpreter to the sample path. I will execute the interpreter, I will see what observables I can extract, and then I can run the same sample in our sandbox with Office where we get all the observables, and then I can actually cross-correlate and see if I find the observables that I find in my report there, and if I find the observables that have been deemed malicious from there also in my report, and then I can cross-validate between the two. And for development, I just go into Office and I try concrete commands to see what they do. And sometimes there are surprising corner cases. For example, the replace function for replacing something in a string in VBA behaves completely differently than the Python function. Instead of going character by character through and then replacing, it replaces, it goes through, finds the first occurrence of the string. So it calls the find function on the string. Finds an occurrence, then it replaces this occurrence, and then it calls the find function again from offset 0. And they are actually using this to confuse people.
Why? Are they winning performances or something with these tricks?
No, because okay. So I was waiting for this. No, it doesn't work.
Yeah, it works. Stop.
Electric. Okay, this is already enough. Thanks. Okay, so imagine you have a string that is like this. So you will go through. Let's say our string that we want to replace is AB. So we have C, ABB, ABBC. If you go through, the implementation of Visual Basic will first find this string, replace it with nothing, and then you have C, ABC, and then this will go together. So you have this, and then it will replace this part, and then CC remains. While Python will go through, will at this point replace, but then will go on in the string, so you will have CABC as result. So just subtle differences.
Which one is correct?
It depends on your specification.
They will not produce the same output, so they are not comparable.
No, but it's, well, Visual Basic, I think the specification of Visual Basic is Visual Basic, so you cannot say that it's wrong or right.
Okay, one other question?
Sorry, the same question, but that means that if you want to replace, say, name with some value x, and x is actually name, you're just looping.
That's a good case. I will check what VBA does on this case. Yes.
Quite interesting.
But I think they have an if to just, yeah, I think, yeah, so what I did in my implementation is I have an if in the beginning to check if the expression that you're replacing with is the same as the one you're searching, and then I'm just aborting.
Other question? Yes? Below first, and after you already have the token.
Thanks for the talk. Have you tried to use the AMC PowerShell on Windows 10? It's a feature on PowerShell to block the execution of the code, and it can be hooked to block just before the execution, and you can catch the obfuscation chain. Have you tried this or?
No, I didn't try this. This could be interesting.
Okay, yeah. In the Windows 10, you can do this.
Okay.
One more collaborator for you.
Okay, we talked about the fact that it was hard to know what was the real ideal behavior of VBA, but did you find some cases where, I don't know, Office 2003 would behave differently than another version, in which case you would have to handle different interpretations?
No, I didn't go this far. So, yeah.
But do you think that might be the case, that there might be such corner cases?
So, if you want to go to the extra slide with the P code, there you actually have this corner case. Because the P code is a compiled representation, and probably what it was for is that just when you have your own document, you open it again, then you have a performance cache, you already have the compiled version. But what they do is they check the Office version and the bitness, 32 or 64-bit, and if it's the same, then you will execute the P code. And this means you can actually remove the source code, just leave the P code, and if you have the correct Office version, the P code will execute, and if you look at the source code representation, it's empty.
Okay, one more question.
Thank you for the call. Sorry for the presentation. I was wondering if regarding this, Did you find any common code with other, groups like APT34 or like other codes like Bondhopper, for instance? Like, there is common sources because it seems to be interesting. The P code is something interesting. Did you see this outside Emotab?
So at the moment, I didn't look at huge amount of documents. This is the next part of the project, to hook it up to the general sample stream, extract all the VBA code and all the objects that I have inside with the tool, and then build a database from that so that we can do cross correlations.
One last question. Yes?
So thanks. In your talk, you talk about many malware things. And have you ever studied like legitimate Office macros, for example, used for in accountabilities or some legitimate use cases? And does this work? Does your tool works fine with them?
So I have downloaded a couple of 100 documents from VirusTotal that have 0 detections, and I'm using those as the test case for goodware.
Thank you all of us for the question, and thanks again, Jonas, for the good presentation.
Thank you.